Yeah. So already we have discussed the time and the space complexity of some of the algorithms. Now we will look at few more algorithms, few more ways of finding the time complexity. So I'll not be writing complete algorithm now, just the piece of code that we have to analyze. Let us look at this. We know this for I assign 0, I less than n, I plus plus. Some statement is there inside. How many times this statement will execute? This will execute for n times. What about this n plus 1? No, we are not interested in this. We are interested in only in this one. Then the time complexity, we can call it as order of n. If you want me to write function, I will write it as n. But if I consider this also, it will be 2n plus 1. But finally, we say this is degree n. Degree is n power 1. So we want this answer. That is the reason I'm not considering this one. So this is the approach we will take now for finding the time complexity. We will find out the time taken by only the statements that we are looking for. Right? So that is the reason I'm not writing a complete algorithm. Take this one. Say that we will just find out the time complexity of the statements that we are looking for. Even if we consider everything, the time is going to be order of n. Now one more thing, again I will revise something, right, before continuing. See, f of x is 5, f of x is 5x plus 3, f of x is 9x square plus 3x plus 4, f of x is 8x cube plus 5x square plus 6x plus 9. I have some functions. What is the degree of this one? What is the degree of this one? Find the degrees. Find the degree. Degree means the highest power 3, highest power of x 2, highest power of x 1, highest power of x 0. So we say this is, instead of x, just you change it to n. So these are n. If this is n, everything is n. X we are familiar with, so I wrote x. Now I have modified it to n. Degree is 3. So we say order of, we don't write 3, we say n power 3. And this is order of n square. Order of n power 1, so it is n. Order of n power 0, so that's why it is n power 0, anything power 0 is what? 1. That's why we write order of 1. So order of 1 means constant. So whatever the polynomial that you are getting for the time complexity of a function, what is the degree of this one? N power 1. Degree is 1. So therefore we write n power 1. So don't have to write 1 as a power. So it is order of n. Okay. So this is, we are writing the degree of a polynomial. Right. So this is a simple way to understand why we are writing order of n. Then there are more things about that one. We will discuss afterwards. You can take this one. This will help you anytime. Most of the student will have confusion here. They think that I am discarding 5n square, discarding 3, discarding 5. It's not discarding. We are writing degree. We are writing degree. Right? Ignore 3, ignore 5, nothing like that. We are interested in knowing what is the degree. Degree of a polynomial is 3, degree is 2, degree is 1. So we don't write 3, 2, 1. We write n power 3, n power 2, n power 1, n power 0. That's all. Let us move ahead. For j takes value 0, I'll start from 1 so that you can easily read it. Otherwise, less than n starting from 0, so sometime it confuses. And j less than equal to n, j plus plus. The statement inside. How many times this will execute? As this is loop inside loop, that is loop inside loop, both are going till n, then it is n square. This is n square. Take this one. So it means if you have nested for loop, it's going to be n square. Already we have seen this, I don't have to explain. Next, now I'm making one change here. If it is not n, this is m. Then what? It is m into n, mn, or nm or mn, whatever it is. We write it as nm. So take this one, I have made change here, right? This is a change. So I have highlighted where I have made a change. Take this quickly, so simultaneously you take it because I have to write, explain, then you copy it. Now, one thing. We don't use multiple variables. Hardly, in some cases we use. When? I will show you. And I will also tell you the reason why we are taking multiple variables there. We take only one variable. So we assume m is equals to n. Assume this one. So therefore, it becomes what? Order of n square. So still, when you have different values here also, so we say order of n square. We assume m and n are equal, and because we want in one variable, so this is square. When m and n are equal, it is square. So take this one, assume m equal to n, and it is n square. Next, I'll make a change here. Oh, I'll put the same thing. Then I'll show you something from this. Then I'll make a change and explain, right? Already the previous one. We know that this is order of n square. Now, let us trace this and find out it is n square. Let us take. What are the values I and j are taking? See, for every value of I and j, this statement is executed. First time I is 1, then enters inside, then j is also 1. Then I is still 1, j becomes 2, then 3, then 4, then every time this statement is executed. 3, then 4, then 5, and goes on up to n. Then it will go back, I will become 2, then again it will start 1, 2, 3, 4, goes on to n. Then I become 3, and again it will start, so on. Then I will become n, that time also j will start from 1, 2, 3, so on to n. So this is the tracing. If you want to write I value every time, then you can write it, okay, 1, then 2, 2, 2. So every time you can write on the value of I also. This is how I and j values will change. Now, let me make it simple. Assume that n equal to 3. Then how I and j will take the values? I will become 1, right? N equal to 3. So I becomes 1. This is 1, 2, 3. So I is 1, 1. Then I becomes 2, 1, 2, 2, 2, 3. Then 3, 1, 3, 2, 3, 3. This is how. So how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 times. So 9 is nothing but n square. So that is 3 square is 9. 9 times it is executing. So if you want, you can take that for n equal to 3. Next, I'll make a change here. Instead of n, I am writing I. This is a change. This is a change I have done. Now I want to know how many times this statement is executed. So for that, I will do one thing. I'll take one variable, say count, that is initially 0. So count plus plus. So how many times this count will increment, that many times that statement will execute. Instead of writing a statement, I wrote count. Okay. So let us find out how many times it will execute. I have changed this one, right? I. So let us assume n equal to 3 only and find out. I value is 1 initially, enters inside j is 1. J is less than or equal to 1. Yes, it is equal to. So what about count? Count will increment 1. It will increment. Alright, then. Next, again j becomes 2. 2 is not less than 1. I is still 1, right? 2 is not less than 1. So nothing will happen here. Count plus plus is not done. In detail, I am showing you now. In detail. Now goes up. I plus plus. I becomes 2. 2 is less than n. N is what? 3. Less than or equal to n. Yes. Enters inside. J is 1. J is less than or equal to I. That is 2. Yes. Count plus plus. So count becomes what now? 2. 1 plus 1, 2. Count became 2. Then j plus plus. J becomes 2. And I is 2. 2 is less than or equal to 2. Yes. So again count plus plus. So this becomes 2 plus 1. That is 3. Alright. So this part 1 and this is another. Next. Again it goes up. And j becomes what? Sorry. J becomes 3. So here it is 2. So 3 is not less than or equal to 2. So nothing will happen. So this is end. Then again I plus plus. I becomes 3. J becomes 1. And this will increment. So this was 3. So 3 plus 1. Now it became 4. Now next I becomes 2. J becomes 2. Sorry. J becomes 2. So this is 4 plus 1. That is 5. Then this is 3. J becomes 3. So this will again execute. 5 plus 1 is 6. Then again J becomes 4. So it will not execute. And I also becomes 4 and it will stop. This is how the I and J values are ticking and count is incrementing every time. Now for 3 it has executed for 6 times. So the value of count is 6. So this is for 3. But if I give 4, what happens? If I give 4, what happens? Right? If I give 10, what happens? Let us analyze this one. See, if I give just n value as 1, then it will execute only for one time. Count will be incremented only one time. If I give n value as a 2, then up to here it will increment. So this is one time, and here how many times it is incremented? 2 times. If I give 3, then 3. So if I give n as a 4, then one more, 4. So if n is n, then it will be up to n. So how many times this count is incremented? If it is 1, 1 time. If it's 2, 2 times. If it's 3, 1 and 2 and 3 times. If it is 5, then 1 and 2 and 3 and 4 and 5. If it is n, then 1 to n. So what is this? How many times it is incremented? 1 plus 2 plus 3 plus goes on to n. This is n into n plus 1 by 2. So this is n into n plus 1 by 2. If I call the function as f of n is equals to n into n plus 1 by 2 only, then this is n square by 2 plus n by 2. What is the degree of this polynomial? Degree is n square. So this is order of n square. I'm not saying big O, omega, anything, theta. I'm saying order of. So when required, then I will talk about big O, omega, all those things. So this is order of n square. Let us say order of. Order means degree. Degree is order also. So order of n square. So I have traced these values and form a table for 3. Then from the observation, I got this one, and this is n into n plus 1 by 2. Alright. So take this one. This will execute for n into n plus 1 by 2 times. Actually, we don't want count. We don't want answer 6. Or if I say 4, then it will be 10. We don't want that answer. We want the formula for any value of n. Any value of n. Not just for n equal to 3. So try to find out the formula. So this, like when I have shown you, you got the idea. But by yourself, you may not be getting the idea. But practicing these type of things, you will get the idea by yourself. Alright, first time you are just looking at it. Second time you will get the idea. Take this. Here I will write some code for I assign 1, I is less than n, I assign I plus 2 and count, or let us say statement. Statement. Now how many times this will execute? How many times? If n is a 10, if n is equals to 10, then how many times this statement will execute? See, I takes the values from 1 onwards, then it will become 3, then it will become 5, then it will become 7, then it will become 9. When it becomes 11, it will stop. So 1, 2, 3, 4, 5 times. So this is executing, this will execute for 5 times. 5 times. If n is equals to 20, then how I will take the values? I will be initially 1, then plus 2, it becomes 3, then plus 2, 5, 7, 9, 11, 13, 15, 17, 19, 21, it will stop because it became greater than 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is executing for 10 times. It is executing for 10 times. This was 5 times. So for n, it will be how many times? N by 2 times. N by 2 times. So this will execute for n by 2 times, and therefore we say it is order of n. Because what is the degree of this polynomial again? N by 2, degree is n only. Degree is n only. Isn't it? See, if you have n square plus 5n by 2, what is the degree? 2 by 100, 2 only. By 1000, 2 only. Degree is a 2 only. Sometimes students get confused. N square by 1000, it's a very small value. How you are saying n square? We are not saying what will be the answer for this equation, for this function. We don't want the answer. We are just interested in what is the degree. Why? We want to know upon what value of n it is dependent. Means what degree of n it is dependent. The time depends on square of n. Right? So degree we want. So n by 2 is also n. So one thing we learn here is that If the function is n by 2, it is order of n. If the function is 100 into n, it's order of n. If the function is n by 10,000, then it's also order of n. Because we are talking about the degree of a polynomial. We are not talking about the value of a polynomial. So this is n by 2. It will execute for n by 2 times, and the degree is order of n. Now one thing I want to make it clear. If I ask you that if the value of n is 20, exactly how many times this will execute, then the answer is 10. If I say, if for the value of n how many times, so you don't know n, then the answer is n by 2. N by 2. Then if I ask order of how much, degree of that function is how much, so it's order of n. That is order of n. It doesn't mean this is not important, this is useless. This is also useful. This is also useful. Alright. So it's n by 2 times. So answer is n by 2 times. What is the degree? Order of n. So what we are interested in, n by 2, n by 100, are we interested in this or degree? We are interested in degree. Okay. Slowly you will understand this. Why in degree? I will not answer now. Afterwards we'll see. So that's it. So for this we got n by 2, and along with that I have explained you that even if it is n by 10,000 also we say degree order of n, and this is also order of n. This is also order of n. They are not equal for some value of n. They are not equal, but degree is equal. Take this, if you have to copy this one, and copy this one also. Now, I assign 1. I is less than root n. I plus plus. This is mathematics. Okay, we are writing mathematical only. This is not allowed in C, C++. Remember, we are writing algorithm. In algorithm, as long as it is giving the meaning, it is correct. So root n. Some statement. Now, quickly tell me how many times it will execute in terms of n, not the answer value 5 times, 6 times. I don't want that. I want in terms of n. I will be incrementing up to equal to root n. I less than or equal to root n. How many times? Root n times order of root n. If it is n, it is n time. If it is n squared, then n squared time root n. So root n time. Okay, then for I assign 1, I into I is less than or equal to n I plus plus. How many times? How many times? I into I less than or equal to, I into I is nothing but I square. We want how many times it will execute. So means up to what value of I it will go. So we want I, we don't want I square. Send square on that side, root n. So I square, I into I is I square. So I square less than n or equal to n. So I is how much? Less than or equal to root n. So again it is same thing only, root n. So this is also root n. Then I will write one more. For I assign 1, I is less than or equal to n into n. I plus plus, some statement. Now clearly you can see how many times? N square times. See, I have not written nested for loop, loop inside loop, but the first loop, the main loop, that single loop itself is n square. So it's order of n square. That's all. Copy these. So we are looking at some pieces of code using loops only, because if simple statement we don't have to analyze. Using loop we are looking at some sample statements and we are trying to find out their time. I'll remove this. Next. Now, next code. For I assign 1, I is less than or equal to n. How many times? This is normally n times, but I assign I into 2 multiplied by 2 now. So the statement, how many times? I is multiplied by 2. So it's not plus 2. Plus 2 means n by 2. Plus 5 means n by 5. But now it cannot be n by 2 or n by 5. It is multiplied. Let us take some examples. If n is equals to 16, how many times? I takes the values 1, 1, then into 2, 2, then into 2 again, 4, then into 2, it is 8, then into 2, 16, then into 2, 32, it will stop. How many times? 1, 2, 3, 4, 5 times. So this is 5 times. Achha. If n is equals to 8, let us see how many times. I is 1, 1 is less than 8. I assign I into 2, I becomes 2. 2 is less than 8. 4 is less than or equal to 8. 8 is equal to 8, then 16, it will stop. So how many times? 1, 2, 3, 4. 4 times. So for any value of n, how many times it will be? For any value of n, how many times it will be? Right? So is it completing it for n times? No. Is it for n times? No. So let us write here. Okay, here I will write. For any n, then how many times? I, then 1, then 2, then 4, then 8, then up to what? Some k times. We don't know what is that k. What is that k? We don't know. So what I'll do is, this is 1, this is 2, this is 2 square, this is 2 cube, right? So, okay, I will observe the same thing here. This is 2 power 0, this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, and then stop. So how many times it has executed? 0, 1, 2, 3, 4. So it is dependent on this power, right? 4 plus 0 also 5 times. So let us look at this 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? And 3, 2, 1, 0. So 0, 1, 2, 3, 4 times. So this is 3. So it is executing for 4 times. So it is dependent on the power. So if I continue, up to what it will be? 2 power some k. So how many times it will execute? That power times. Power plus 1. So roughly power times. Right? Power plus only you take. Right? So that many times. So this is 2 power 4 has became equal to this, greater than this one. So it has stopped. And here 2 power 5 became greater than this one. So it has stopped. So same way 2 power k, when it becomes greater than n, it will stop. So terminates if 2 power k is greater than n. So let us assume this as equal to n. So what is k? k is log n base 2. Log n base 2. As we observe that k plus 1 times, so okay, k plus 1, that is nothing but log n base 2. So k plus 1 is log n base 2 plus 1. So therefore it is order of log n. And by default it is base 2 only. In computer sciences and analysis we say base 2, log n base 2. So once again I'll show you. See, it was executing 5 times and 4 times for n equal to 16 and 8. So for n, how many times? So that number of times actually depends on the power. Last power is 5, stop. Last power is 4, stop. Last power is k, stop. So when it has stopped? When it is k. When it is k. And that is starting from 0 onwards, right? So when it became 2 power k, it has stopped because 2 power k has become greater than n. So 2 power k is greater than n, it will terminate. So if I equate and say, then k value is how much? Log n base 2. So this is log n base 2. So I have given you examples, then based from the examples I got the idea that okay, this is increasing like this and it is dependent on the power. So I found out power is log n. Alright. Take this one, I'll explain the same thing once more in a different way. Two into 2 into 2 into 2 is 16, right? How many times multiplied? 4 times. 2 power 4 is equals to 16. This is power operation. Answer is 16. Inverse of power operation, 4 is equals to log 16 base 2. What does this mean? Log 16 base 2 means what? Means what? Let us see. If I take 16 and divide by 2, then divide by 2, then divide by 2, then divide by 2, I'll get the answer 1. So it means if you divide 16 repeatedly by 2 for how many times, you will get the answer 1. Again I repeat, if the number is 16, how many times you should divide it repeatedly by 2 to get the answer as 1. So I have to divide it for 4 times. That is the meaning. Log 16 base 2 means if 16 is divided by 2 some number of times so that it becomes 1. So how many times it can get divided? 4 times. Here, how many times 2 should be multiplied with itself to get the answer 16? So 4 times. 2 power 4 is 16. Then 16 should be divided by 2 for 4 times to get the answer. Divided by 2 for 4 times to get the answer 1. So inverse of power is log. Inverse of power is log. Like addition inverses subtraction. Multiplication inverses division. Same way log inverses, power inverses log. That's it. So log is like this. So what we are doing here? Multiplying 2 and 2 and 2. So it is reaching till n. So after how many multiplication it will reach till n? So we can know this value by log only. So log 16. See, I is 1. Then it is becoming 2. then again 2, then again 2, and some more time, and it is becoming greater than n, greater than n. So how many times this is multiplied? So 2 power k times is greater than n. We don't know how many times, so k. So how many times it is done? K times. So k is how much? Log n base 2. So that's how we got the answer, log n base 2. So I is multiplied by 2, multiplied by 2, multiplied by 2 for some number of times so that it became greater than n. So how many times? K times. So it is log n base 2. Now, next. Okay, I'll change this, sorry. I'll rewrite the whole thing. For I assign n, I is greater than 1, I assign I divided by 2 and some statement. Now how many times? How many times? Find out this one. I is n. I is n. Next time I by 2. So I is n. So n by 2. Then again I by 2. So again it is divided by 2. So 2 square. Then again divided. So n by 2 cube. Goes on. Up to 1. N by 2 cube. And when it will stop? When it becomes less than or equal to 1, it will stop. Here it will stop when it becomes 1. So how many times this is getting divided? We don't know. So let us say this is done for how many? Okay, this is reaching till 1. So we don't know how many times it is done. So we say this has became n by 2 power k, which is equal to 1. So for some k times. So repetition is for how many times? K times. So since it terminates when I become less than or equal to 1. So therefore, we assume I has become what? N by 2 power k, that is less than equal to 1. So n by 2 power k is equals to 1. So n is equals to 2 power k. So what is k? K is equals to, okay, here I continue. N is equals to 2 power k. So k is log n base 2. Log n base 2. So again we got the same answer, right? So whether it is multiplied or divided, answer is same. Okay, take this one, take this. Now let us write one more piece of code. For I assign 1, I is less than n, I plus plus. Right, when it becomes n, it will stop. Less than n I wrote, less than or equal to n also you can write. I starts from 1 and when it becomes n, it will stop. Then here I will take one more variable j, which is 0, and inside this I will say j plus plus, j plus plus. And now I am changing the condition. Watch it carefully. J less than n. Can you tell me when this loop will stop? I have not given I have given j. So j is less than n, so when this loop will stop? Let us analyze this. So we have I and j. Initially I is 1 and j is 0. First time j is less than n. Yes, j is less than n. 0. It is 0. We don't know what is n, right? So I plus plus I becomes 2, right? Sorry. I'll just make a change here. I thought I am writing this one. J assign j plus I. I just wrote j plus plus. J assign j plus I. Let us do this, right? I is 1 and j is less than n. Yes. So in j, this I is added. So j becomes what? 0 plus 1, 1. The next I plus plus I becomes 2. So in this, first is I is 1. The next step is this one and this one. So first step is this one and second step is this one and the third step is this one. First I was 1, which already I wrote it. Then j is modified. I have to show it in the next step because initially j is 0. Then I plus plus, right? Otherwise, if you say no, this is confusing. So let us do it like this. J is 0. Then this is 0 plus 1. First step, I is 1, 0 plus 1. Then I became 2. I became 2. Then again, this is 1. 1 plus, then plus I, 2. Alright. So this is 3. So I will not add it. 1 plus 2 I will say. The next time I becomes 3. So it is already 1 plus 2. So 1 plus 2 plus 3. 3 is added. Then I is 4. So this is 1 plus 2 plus 3 plus 4. How many times this loop will repeat? This will repeat for how many times? Is it for n time? No, it is dependent on j. And j, something is happening to j. It is not going linearly plus plus plus. So j assign j plus I. So we can't say how many times it will execute. So when you can't say that this will repeat for some k time. So this is how much? 1 plus 2 plus 3 plus 4 plus goes on to k. And it will terminate. So what is the condition we are checking? J less than n. So what is j? J, this one. Do you know this one? What is this? K into k plus 1 by 2. This is j. And what is the condition? J less than n. So it will terminate when? It will terminate when j becomes greater than k into k plus 1 by 2. Sorry. J becomes greater than or equal to n. As long as it is less than n, it will continue. When it becomes greater, it will stop. So what is j value? J value is k assign k into k plus 1 by 2 becomes greater than or equal to n. So k into k plus 1 by 2, let us say it is equal to n. Then what is k? What is k? This portion is quadratic in square. Assume that this is roughly k square is equals to n. So k is approximately n, root n. So this is root n time. This is not exactly. So roughly it's k square equal to n. So k is equals to root n. So we say the time is root n. Time is root n. So you can copy this one.